Dear students, welcome to the fifth week of our class. We are coming to the midterm exam in 2-3 weeks period of time, and we will go into details, start to go into details for offshore production engineering. This week topic will be regarding on the offshore drilling and the production platforms and the units including in these platforms. Okay, so let's go on. Okay, so offshore drilling and production platforms units, topic of this week. Okay, let's start with the drilling and the production platforms, okay? So to drill an oil and gas well in the middle of an ocean or sea is totally essential to have, it's totally vital, it's totally crucial to have some platforms on which necessary drilling equipment and other accessories can accessories also the ancillaries can be replaced, okay? So let me open this. Yes, can be replaced. So as discussed in previous weeks, okay, depending on whether the type of the well is exploratory or development in nature, or the type of the platform can be fixed or mobile, okay, according to the situation it can change, and the location as well. The term platform we call signifies some type of structure, and in between these major types of structures, there is one more category known as compliant type platforms, okay? Not only the fixed platforms that we are talking, the complete type of platform we are talking about. So which has its own application, okay? Complete type platforms has its own application depending on the number of the wells to be drilled planned before, okay? The type of the facilities here to be installed on the top side, for example, oil rig, living quarters, the helipad, and so on. The depth of the water, that is, if it is shallow, for example, less than 3 meter depth, or ultra deep, more than 1,500 meter. Practically of methods of construction, fabrication, and installation, and also the meteorology and the oceanography, and finally the economics, which varies different for each different projects, okay, globally, worldwide. So from one place to another, it will show lots of differences. So because of that, we have to be concentrated on these parameters separately and uniquely, all right, according to each project uniquely, all right. So offshore platforms, according to these parameters, in the light of these parameters which calculated, these platforms can be broadly categorized into three different types, three different groups. So one of these is the fixed platforms, okay, and the other one is the compliant platform, and the mobile platform and units, okay. So three different types we will talk about, all right. So first of all, fixed platforms we will talk about. The fixed platforms actually, these are those whose leg or base is fixed at the seabed forever, okay, either by way of penetrating to the seabed by it's penetrate directly to the seabed, or by its own weight, okay, by its own weight it's stabilized to the seabed, okay. So moreover, they remain fixed at one place and cannot be moved to any other location. Impossible. So different types of fixed platforms we have. These are, first of all, the jacket platform, all right, jacket platform. The four type of these jacketed platforms. One of them is the well protector platform, tender platform, self-contained template platform, sorry, self-contained tower platform. So four different type of the jacketed platforms is available in the industry, in the market, okay. So let's go for the second one is the gravity platform. The other one is the gravity platform. So by its own weight, it's stabilized through to the ground. All right. So we will go into details of all of these. Okay. So go on. Okay, we will talk about the jacketed platform in here. So first of all, what we can say about the jacketed platform, the term jacket we have to explain. The term jacket here means a steel structure in the shape of the translated pyramid that rises from the seabed to above the water line, it says, okay. So this is built from the tubular steel members and not structural irons. Okay, the material is steel now instead of iron. Keep it in your mind. The cylindrical shapes of the tubular members create less resistance to waves and currents, reducing the amount of steel and thus its weight, also its cost as well, right? Okay. So other than the jacket here, the jacketed platform itself, as you can see in the picture, in the figure here, with its all materials and units included, the deck substructure in the upper part and the jacket part in the lower part, okay, with the legs and other things. Okay, so what we can say here, other than the jacketed platform consists of decks or the spare structure on which the drilling, production, and all other equipment rest, and piles which are driven through the leg of the jacket for securing the platform to the seabed. Okay, all right. So the spare structure here generally comprises three decks they call. Okay, so one of them is the drilling deck in the upper part, as you can see, or main deck, drilling or main deck. If you can see both structure, both names, it can be drilling deck or main deck. The second one is the wellhead and the production, or you can see it as the mezzanine deck. Okay, mezzanine deck is the old term they are talking about. So mezzanine deck or the production deck, all right, wellhead deck, all of these are suitable to see in the literature. Another one is the third one is the cellar deck. Okay, the cellar deck. Also, in the cellar deck, also another name they called here cellar deck, as you can see. All right. So another name that they called. All right. So okay, so let's go with this one. Let's go with this one into details. So these decks are supported on a gridwork of girders, trusses, and the columns in two different rows. Let's say A and B, as you can see in here, of four columns mainly. So it's the basic structure, okay? Basic structure of four columns, 1, 2, 3, 4. Okay, so each in typical 8-leg jacket platform, right? 8-leg jacket platform, as you can see in the figure. So the bottom ends of the deck columns are joined with the piles which protrude from jacket legs after being driven through them. All right. So this is the main structure of this type of platform. So we already gave this one. All right. So the jacket actually here, the jacket consists commonly of 8 large diameter tubular legs, which framed together by many relatively smaller sized tubular members known as braces. Okay, they call it braces. Okay. So these braces can be of three types. One of them is the horizontal braces. Okay, so as you can see in the first one, the horizontal bracing. The second one is the diagonal bracers, diagonal bracing here, as you can see. All right. The third one is the X or K type bracing. So these are, as you can see, in A, X bracing type, and the K bracing types also given in here. Okay. So the designer, from his experience, decides of the framing plan, but the most common framing pattern or truss work is of the Warren bridge type, as shown in the figure. This is the Warren bridge type. You can see X type, K type, horizontal bracing and diagonal bracing, and we call this one as a Warren bridge type, shown in the B part. All right. So the leg spacing at sea deck level above mean water level. Okay, we call mean water level. Maybe you are familiar with this one. MWL, mean water level, in the longitudinal direction is approximately, for this one, is 36 to 45 feet, nearly 10 to what? 12 to 15 meters. Okay, and the spacing between the two legs, two central legs, is approximately 45 to 60 feet. So this is 15 to 20 meters. So depending on the availability of launch barge, and the spacing between large runners on this page actually. So the leg spacing in the transverse direction is approximately 45 feet, which depends on the dimensions of the drilling and production package to be placed on the deck. Okay. So the decks normally extend, and overhang beyond the boundary and outlined by the jacket legs by about 12 to 15 feet. Okay. So let's say 4 to 45 meters, and the jacket legs, which vary in size and with large diameter corner legs and smaller diameter central legs, and not actually not vertical but battered, that is, they taper out from the top, and as a result of the bottom, the base size becomes larger, giving the advantage of stability by resisting the environmentally introduced overturning moment. Actually, so the legs usually have better varying from the ratio is 1 to 7, between 1 to 7 to 1 to 12. Okay, for this way. Okay. All right, let's go. So other than these three main components of this 8-leg platform, that is jacket superstructure and piles, there are some auxiliary elements in it, all right? Those are skirt pile sleeves, drilling area, deck substructure, and the deck modus, and the drilling area, conductor riser area, including that one. Boat landing facility, barge bumpers, launch runner, and these type of small units as well are used to combine this all jacket. Okay, so skirt pile sleeves are used for driving skirt piles in between main piles around the periphery of the jacket leg, whatever. All right. So I'm just giving you this as an information, to general information, to make you familiar with this type of environment and the tools used in building the legs and other things of a platform. All right. So these skirt piles are used to increase the capacity of the structure in resisting the overturning moment. Actually, all right. Okay, go on. So there are two main types of the well jackets: the slipover type and the development type. Okay, so the platforms built to protect the risers on producing wells in shallow water are called well protectors or well jackets. Okay, let's go from this way. So usually a well jacket serves from 1 to 4 wells. It's capable to serve from 1 to 4 different wells at the same time. So such as platform may be either one large pipe or occasion or an open lattice truss template jacket structure. It depends on the how the structure and the template is. So there are two main types of well jackets we mentioned. We said slipover type and the development type. Okay, two main categories. So both types protect the well or the wells, as we said, 1 to 4 well is possible, from ship collisions and the environmental forces. Okay? So the slip-over jacket is used for exploratory wells in 50 to 100 feet, so maximum 30 meter, 35 meter water depths. After the well is drilled through a occasion driven a few feet into the sea bottom, a well jacket is slipped around the occasion itself. Okay, so this jacket is a four-leg structure with one side open, meant for slipping around the well. So the open side may be later be added with additional bracing or etc. Right? So it normally serves one well only. Right? Let's keep in mind. So on the contrary, the development jacket may accommodate several wells, and this is installed prior to drilling. So this is used in conjunction with mobile drilling units like jackup or semi-submersible. All right. So that after the mobile unit leaves the site, the well conductors or production risers are protected by the four-leg jacket, for example. So while drilling, the slots in the drilling vessel or the cantilevered portion of the jackup is positioned above the top open portion of the translated pyramidal structure of the jacket. Okay? Okay. The second one we call is the tender platforms. Okay? So tender platforms we will talk about. The tender platform is used as commonly known as it was 40 years ago. The same structure still well, right? In terms of size and operation, it falls between the well jacket and the self-contained platform. It says generally the drag and the substructure, primarily power supply and mud pumps, are placed on the platform. Okay, so generally what we can say about the tender platform, generally the derrick and the substructure of that, the primary power supply and the mud pumps are placed on the platform itself, on the platform. So the drilling crew quarters, remaining equipment and supplies are located on the tender ship. Okay, tender ship which moored adjacent to the platform, right? So the two are usually connected by a long walkway. Okay, long walkway. So here you can see that type of platform. So these two are connected. So one of them gives all the equipment, supplies, and other things, and the other one is the drilling part. Okay, responsible for drilling part. Okay. Another one is the self-contained template platforms. The self-contained platform is a large, usually multiple-decked platform with adequate strength and space to support the entire drilling rig with its auxiliary equipment and crew quarters and enough supplies and materials to last through the longest anticipated period of bad weather when supplies cannot be brought in. So the self-contained platform, template platforms, actually, according to the bad weathers it designed. So the bad weather period is normally 3 or 4 days. So the platform should accommodate supplies and materials for approximately twice this time. There are two types of self-contained platforms: the template type and the tower type. So we are in template type now. Okay. So the tower platform is actually also a template structure, but shows some differentiations we will discuss. However, the piles are driven in a different manner for that. All right. So the most common type of shore structure in service today is a template jacket structure, as you can see in the figure, jacket structure type. Okay. Okay. So the term template is derived from the function of these structures actually to serve as a guide for the piles. So the piles, after being driven, are cut off above the templates and the deck is placed on top of the piles. So the template is prevented from settling by being welded to the pile tops with a series of rings and gussets. So hence the template carries no load from the deck but merely hangs from the top of the piles and provides lateral to support to them. So self-contained template platforms actually have been designed and constructed in many sizes and shapes itself. Okay? So early template structures had many legs and including in the below the jacket part. All right, so that's what we can say about self-contained template platforms. Another one is the installation of template platforms. So the installation procedure actually is classified with different for the installation of these template platforms. Procedure varies and shown in here. Actually, installation of the platform consists of transporting the various components of the platform to the installation site, positioning the platform on the site, and assembling the various components into a stable structure in accordance with the design. So according to these changes, the installation procedure is classified as below within 6 different bullet points in here. First, transportation. Maybe more will come. I think it has to be more than that, but we will see. So first, transportation. Second, removal of jacket from the transport barge. The erection part, the pile installation, superstructure installation, grounding of installation, and welding equipment. Okay. So here I would like to concentrate on erection and the pile installation part, the two different parts. So all these operations are will be discussed in later weeks. Okay, in the second part after the quiz, after the midterm. So we will discuss all of these. So okay, let's go with that one. It's always necessary to maintain a pile installation record in which the following are noted. So we have to record these things. First of all, the platform and the pile identification is crucial. Okay, so penetration of a pile under its own weight. Below counts throughout driving with hammer identification. Penetration of pile under its own weight and the weight of hammer itself. Okay. So unusual behavior of hammer or pile during driving, interruptions in driving, including the setup time. So we have to care about this and some more I have actually. Let's go into details. Lapse time for driving each section. Elevations of soil plaque and interval water surface after driving. Actual length of each pile and cutoffs. Pertinent data of similar nature covering driving, drilling, grouting, and concreting of the grouted or belt pile section. Okay, so grouting. Another one is the grouting that we can talk about. The grouting following this one, after including the procedure of these 10 steps, the grouting is the next step that's performed after peeling. Okay, after peeling. So for this, there is a growth line for each leg and sleeve, which is connected to the bottom of the leg. And the cement slurry is pumped into this, and from the top, return water present in the annular space comes out through an outlet connection. So after some time, when the cement is fully filled, all right, in the annular space I'm talking about, the cement starts coming out. So the samples of the cement slurry going in and coming out of each leg, and sleeves are taken and the cubes are made out of them by placing in wooden frames, which are later sent to hardness tests to get an idea of cementation in annular space. So divers survey the cementation of sleeves, right? Okay, so these are the main things that I would like to give you regarding on the week 5. So if you have any questions, all right, if you have any questions, you can ask me directly, or you can write me in any time that you are available. So my website can be seen in the down part here, all right. So you can see that one, and you can write me anytime you want regarding on any questions if you have, especially before the midterm exam. Okay, all right, take care.